Hello students, once again welcome back to my channel. This is Soil lecture series for JRF, SRF, ASRB NET and other related competitive examinations in the agriculture field. We are dealing with the quantitative relationship between the soil constituents. We have seen particle density, bulk density, factors affecting bulk density, relationship between them, specific volume, and in the last lecture we have seen the total porosity. So we have dealt in detail. Now I am teaching about some terms which are the continuation of that topic. So first one is a void ratio. So let's look in detail. Excuse me. Okay, so void ratio, we have seen what is porosity. Porosity means the volume occupied by the pores per unit volume of the soil. So the volume means total volume. In total volume, how much volume is occupied by the pores, that is known as total porosity. But what is the void ratio? It is the volume occupied by the pores per unit volume of soil solid. So how much volume is occupied by the soil solid, in that how much volume is occupied by the pores, that is among the total volume or unit per unit volume of soil solid, how much volume is occupied by the pores, that is void ratio. Void means pore, so pore ratio means volume occupied by the pores divided by or volume occupied by the pores per unit volume of soil solid. So we represent it as a fraction. Porosity we represented as percentage, or we can represent as fraction also, but void ratio, it is fraction. So its range is between 0.3 to 2. 0.3 and 2. It lies between 0.3 and 2. In case of porosity, it lies between 0.3 and 0.6. Is it 0.3 and 0.6? So, but void ratio, it is between 0.3 and 2. Then it is an index of relative volume of pore. Like porosity, also it is an index of relative volume of pores, but what relation? In what relation? In relation to the volume of soil solid. In we know in the soil there are soil solid and pores. The pores are occupied with water or air. Water and air, we can say. So per unit volume of soil solid, how much volume is occupied by the pores? So in relation to the volume of soil solid, how much volume is occupied by the pore? That is a void ratio. Void ratio is greater than porosity. This is an important point. Why it comes so? Because volume of soil solid is less compared to total volume of soil. In porosity, we have a total volume of soil below. So this is less. So what will be more? This void ratio will be more, because when compared to total volume of soil solid is less. These are inversely proportional. If this is less, this is more. So void ratio is greater than porosity. In the equation of porosity, we are dealing with the I will show per unit volume of soil. So when compared with the per unit volume of soil, uh, the soil solid is a part of soil, total volume of soil. So void ratio will be greater than porosity. So then the relationship between void ratio and porosity, void ratio E is equal to F by 1 minus F. Here F is a porosity. So porosity divided by 1 minus porosity. That is the equation for void ratio. If any numerical problems comes, then you can use this equation. So you don't want to by heart it. This 1 minus porosity. Porosity, here we are using fraction. So 1 means it will be total volume. From total volume of soil, if we minus or if we subtract the volume of pore, that means porosity, what we will get? Unit volume of soil solid. So total volume minus pore space means volume of soil solid. Then volume occupied by pores, simply it means porosity. So by 1 minus F is a void ratio. I hope everyone understood this concept, this definition. So void ratio means volume occupied by pores per unit volume of soil solid. And this is a difference between porosity and the void ratio. Porosity is the volume occupied by the pore per unit volume of soil, while the void ratio is the volume occupied by the pores per unit volume of soil solid. Porosity is used in agricultural purpose, while void ratio is used for engineering purpose. Then it's a fraction 0.3 to 0.6, while void ratio 0.3 to 2. Then porosity we can represent as fraction or percentage, while void ratio only fraction. Then void ratio is greater than porosity. Everything I have discussed. The next is the mass wetness or gravimetric water content. Gravimetrically, how much water is present in the soil, that is the mass wetness. It is a mass of water per unit mass of oven dried soil expressed as percentage. Expressed as percentage means into 100. So per unit mass of oven dried soil, that means per 1 gram, how much mass of water is present in the soil. So actually we represent the water as a liter, milliliter like that. But here mass, we are taking the weight of the water. So for that we represent the mass wetness as fraction or percentage. The range is between 25 to 60 percentage. That means when 100 percentage weight of the soil, 25 percentage 20 when like 100 gram of the soil, 25 gram to 60 gram, it will be mass of water. It is a common range. It is a range of the water present. Okay, so it is a range of the mass wetness or gravimetric water content in mineral soil depending upon the bulk density. So when there is any word like gravimetric, gravimetric usually means gram, weight in mass basis. So gravimetric means mass weight basis. So mass wetness or gravimetric water content is a mass of water per unit mass of oven dried soil into 100. So saturated water content 100 percentage. It is a maximum water holding capacity. So mass wetness 100 percentage means it is saturated. It is a maximum water holding capacity. We will not say water content as 110, 120 like that. 100 is a maximum water holding capacity of the soil. Saturated water content will be higher in clay soil. You know that because in sandy soil it will not retain water, but in clay soil it will retain water. So saturated water content will be more, or clay soil can hold more water than any other soil. And saturated water content may exceed 100 percentage in organic soil or peat or muck soil. So organic soil is also known as peat or muck soil. In that saturated water content, that means it will be, it can be more than 100 percentage. So saturated water content is usually 100 percentage, which is higher in clay soil, but in organic soil it will be more than 100 percentage. That is a point. So mass wetness or gravimetric water content is a mass of water per unit mass of oven dried soil into 100. The next is a volume wetness or volumetric water content. So here we are considering the volume instead of mass, volume of water occupied in the pore space by total volume of the soil into 100. So per 1 centimeter cube of the soil, how much volume or how much milliliter or how much centimeter cube of the soil is occupied by the what water in the pore space. It is also represented as fraction of percentage. At saturation, water holding capacity is equal to porosity. So saturation means all the pores are filled with water. You know that. So water holding capacity, water volumetric water content at a saturation is equal to porosity. Why? Because at a saturation, all the pores will be filled with water. Then volume of what is volumetric water content? It is a volume of water occupied in the pore space per unit volume of soil into 100. So in pore space, if everything is filled with water, it is saturation. So that's all. In clay soil, volumetric water content exceed porosity of dry soil because of swelling on wetting. So in clay soil, what is the peculiarity? It swells, its volume increases. So more than in clay soil, because of the swelling capacity, water will fill in pores, and also it is exceed, it will get retained on the soil. So more than porosity it will fill, it will fill exceeding the pores. So that's why volumetric water content exceed the porosity of dry soil when it swells on wetting. In sandy soil, volumetric water content is between 40 to 50 percentage. So medium textured it is 50 percentage, and clay soil 60%. So volume wetness or volumetric water content range is between 40 and 60. It is it can be represented as fraction also. So in fraction it will be 0.4 and 0.6. So 0.6 or 60 percentage comes for the clay soil, while 40 to 50 percentage comes for the sandy soil. So sandy soil volumetric water content is less, but clay soil it is 60. But in clay soil at volumetric water capacity, when it swells, it exceeds the porosity. The next is the degree of saturation, which is represented by percentage. It is the pore volume occupied by the water, whole divided by total volume of pore into 100. So here we know the volumetric water content is the volume of water which is occupied in the pore space per unit volume of the soil. As a whole soil, how much volume is occupied by the water in the pore space. But look at the degree of saturation. It is the out of total volume of pore, how much is occupied by how much pore volume, how much pores or how much volume is occupied by the water in pore, expressed as percentage, that is the degree of saturation. There are difference. Volumetric water content is out of total volume of soil, while degree of saturation is out of total volume of pore. That is a difference. So it can be, the range is between 0 to 100 percentage. So complete saturation is rarely attained under field condition, since some air is always trapped in even in the very wet soil. So it's saying that if any sentence comes for the exam like complete saturation is attained at the field conditions always, it is not correct. See that, because in a very wet soil some air can be trapped. So if there is some air, total volume of the pore will not be occupied by the water. So degree of saturation will not be 100 percentage. So complete saturation is rarely attained under the field condition. So it is under the field condition. In complete saturation can be attained, but in field condition it is rare because air can be trapped even in the very wet soil. Then air-filled porosity. So understand the difference between volumetric water content and the degree of saturation. So next is the air-filled porosity. Air-filled porosity. So here in this word itself there is a word air. Filled porosity. Porosity means, you know, pore. Porosity means pores. Air will be, see two words, air and pore. So it is a pore volume occupied by the air by total volume of the soil. So in porosity, in the case of porosity, we will deal with we usually talk about whole volume of the soil. So in that total volume of the soil, how much pore is occupied by air? That is a air-filled porosity. So when it is expressed as percentage, it is known as air-filled porosity. So it is important criterion for the soil aeration, because air-filled porosity, if it is high, it means the soil is well aerated. Okay. Then air-filled porosity. While teaching that, I forgot to tell that air-filled porosity. If we subtract the volumetric water content from porosity, we will get air-filled porosity. Because volumetric water in the actually soil, 50% is the solid space and 50% is pores. So out of 50% pores, half is filled with air and half is filled with water. So in pores, total pores, when we subtract the pores which is filled with water, that is the volumetric water content, what we will get? The pores which is filled with air. So that's it. Air filled porosity is porosity minus volumetric water content. And degree of saturation is volumetric water content divided by porosity. Just we can derive this equation from that. No need to by heart it. If any problem comes, only this equation matters. Gravimetric water content is volumetric water content divided by bulk density. This is important. Gravimetric water content is volumetric water content divided by bulk density. This is the relationship between gravimetric water content and volumetric water content. The next is depth of water. Depth of water is equal to volumetric water content into depth of soil layer. So depth of water, how much depth the water is filled. For that, we need to know how much depth is how much deep the soil layer is and how much volume of water is present. So volume of water into depth of the soil layer gives the depth of water. And weight of furrows lies per hectare. So here when dried weight of the soil of 1 hectare area to a depth of 15 centimeter. That is a weight of furrow slice up to 15 centimeter depth in 1 hectare area. How much weight of the soil is present? That is a weight of furrow slice. This weight is used for calculating the amount of fertilizer, amendment, etc. So when we come about fertilizer and amendment calculation, we can use this weight of the furrow slice. So its equation is bulk density into depth, furrow slice depth in meter into area of 1 hectare. So bulk density we will use 1.33. Then furrow slice here 15 centimeter, that is 0.15 meter. Then area of 1 hectare. 1 hectare means 10,000 meter square, that is 10 raised to 4. So we will get 1,995. So approximately 2,000 megagram. That is 2 into 10 raised to 6 kg. So this is the weight of furrow soil 2 into 10 raised to 6 kg. This is an important with regarding to the problems. So that's about today. Like we have seen the void ratio, then mass wetness, volume wetness, degree of saturation, air filled porosity, depth of water, then weight of furrow slice. These are the terms that are given in the fundamentals of soil science book. If you want the notes, then you please comment in the comment section. Please, if you comment only, I will get to know that. And if you want a separate telegram channel or like that, please say, then I can share the notes, because sharing notes is not easy, or we can't share notes through YouTube, you all know that. So if you want notes, then please let me know, then I will do whatever we need. So that's about all about our lecture of today. Please watch the previous video also. Thank you so much.